The question that I have is, could you illustrate the use of the principle of moments via an example? Say you have a problem that involves a beam, right? In most cases, the thickness of the beam is negligible in comparison to the dimensions in the length direction. But in some cases, it may be significant, all right? So you may want to consider that. Now, obviously, the thickness of the beam has to be given to you for you to be able to consider that in your moment calculation. So this is an example where the thickness of the beam is given. So here are my calculations for the moment of these forces about point A. I'm using the method based on the principle of moments. And here is my XY coordinate system, and here are the components of these forces with respect to these directions. And here is the sum. So 30 sine 40, which is this one right there, right, has a perpendicular distance of 2 meters. And that's going to give me a counterclockwise moment. So I have a positive sign in front of that. So the 30 sine 40 multiplied by 2. And this 30 cosine 40, right? So in this particular case, our thickness of the beam, half the thickness of the beam is 0.3 meters and it's given. So this line of action is no longer passing through point A. Point A happens to be the center of the beam, right? So there is a moment arm, which is 0.3 meters, and the moment of that force is therefore 30 cosine 40 multiplied by 0.3, and it's also going to give me a counterclockwise moment. So I have a positive sign in front of that. And just try to understand this a little bit more, because this is the unique part of this example here, right? All right, so now we go to the second force, 20 kilonewton, and we see that the point of action of that force is right on the center line of that beam, and therefore the horizontal component still passes through point A, and it does not make a contribution to the moment equation. And the vertical component, or the y component, is 20 sine 40, and that has a perpendicular distance of 2 plus 2, which is 4 meters, right? All right, so you simplify that, and you get 96.88 kilonewton meter out of this.